Hey guys, so this is the first video in our distance learning section. It's the first instructional video that I've made for this section. So we're going to start with molar heat of vaporization and molar heat of fusion. So basically what that means, molar heat of vaporization is the amount of energy that is required to convert a liquid to a gas. Molar heat of fusion is the amount of heat that's required to convert a solid to a liquid. So in this problem, we're working with both of them. As I work through this problem, I'm just going to write what I'm doing out to the side. So if you need to back up or rewind, you can do that and see why I did what I did. So the two equations that we're going to be working with are both pretty much the same. Delta H equals the delta heat of fusion times the mass over the molar mass. This is how we calculate how many kilojoules are going to be required to melt ice into water. So that is the first step of this problem. The problem says how much heat is required to convert 25 grams of ice at 0 degrees Celsius to steam at 100 degrees Celsius. So that means that the first thing we need to do to solve this problem is going to be to melt the ice into water. So we need to melt the ice into water and apply the right amount of heat to make that happen. So I'm just going to plug into this equation what I know. Delta heat of fusion for water is 6.01 kilojoules per mole. You need to know that number if you don't already. You should have it in your notes. And delta heat of vaporization for water is 40.6 kilojoules per mole. Remember, the reason that the delta H of vaporization is higher than the delta H of fusion is because you have to break the intermolecular forces to vaporize something. So I'm going to go ahead and plug what I have into this equation. Delta heat of fusion is 6.01 kilojoules per mole. My mass for this is 25 grams. That's given to me in the problem. And I'm going to put it over the molar mass. Molar mass of what, you might ask? Molar mass of water. So if I add the weight of 2 hydrogens to the weight of 1 oxygen, I get 18 grams per mole. So this is how I figure out how many kilojoules are going to be required to convert that 25 grams of ice into a liquid. So this is the first step of that equation. I'm going to go ahead and put this into my calculator. I uploaded a calculator for you to Schoology. So even if you don't have a TI calculator at home, you can use that one that I posted on Schoology. 8.347, my units for this are kilojoules because I'm talking in terms of heat. So that's the first step. Now moving on from that, we actually aren't going to use information from the first step in the second step. We're going to put that aside for just a second, but we need to keep this number in mind. So step number 2 is going to be to raise the temperature of the water, because what happened here, we melted the ice into water. We have this 8.347 kilojoules. That's how much it needs to make the whole thing into a liquid. So now I need to raise the temperature of that liquid from 0 degrees Celsius to 100 degrees Celsius. So I need to raise the temperature of the liquid from 0 degrees Celsius to 100 degrees Celsius. In order to do that, I actually need to use a specific heat equation. So step number 2 is going to be to use a specific heat equation. And I already know all of this information. So my delta H is the thing that I'm trying to find, or you could use Q if you're more familiar with that. And then I'm just plugging this into MCAT. So MC delta T. My mass for this is still 25 grams, and I got that from the problem, so nothing changed here. C, my specific heat of water is 4.184, and delta T is me changing this from one temperature to another, so it's going to go from 0 degrees Celsius to 100 degrees Celsius. Okay, so I'm going to put this into my calculator. 25 times 4.184 times 100. And that gives me a big number, but that's okay. So the number that it gives me is 10,460, and that's still kilojoules. Remember, this shouldn't be surprising that it takes more energy. The higher state of matter I get to, the more energy it takes to change things. So now I've raised the temperature of the liquid. This is how much it's going to take to raise the temperature of the liquid from 0 degrees Celsius to 100 degrees Celsius. All right. Step number 3, again, we're just moving on. We're not using any of the information from the problem before this in this problem. The next thing we need to do is convert the water into steam. So if you're following this, we melted the ice into water, We raise the temperature of the water. Now we need to convert it to steam and break those intermolecular forces. So to convert this to steam, I'm going to use my equation for heat of vaporization, which is actually exactly the same as the one for heat of fusion, but we're plugging in a different number right here. So my equation for this is delta H equals delta H Vap times a mass divided by the molar mass. So really not much has changed in this equation. So when I go to convert something to steam, I'm going to use my delta H vaporization. So I'm going to set this up with the information that I have. My delta H of vaporization is 40.6 kilojoules per mole. My mass has still not changed. I still have 25 grams of this substance, and my molar mass has not changed. I still have 18 grams per mole. So I'm going to put this into my calculator. The 40.6 times 25 divided by 18, that gives me 56.39, and I'm still in kilojoules. So here's what I've just calculated. This is how much energy it takes to melt the ice into water. This is how much energy it takes to raise the temperature of the liquid to a certain temperature, and this is how much energy it takes to convert it to steam. So to find the answer to this question, how much heat is required to convert this to this, I have to add all of these together. So I'm going to add that 8.347 plus 10,460 plus 56.39 kilojoules. I'm going to add it all together. And this was my answer. The very last step in this problem is to look at sig figs. Remember, we do not use temperature for sig figs. Don't use temp for sig figs. So we're looking at the mass. That's the only other number that we have. It's going to be the 25.0 grams because that's the measurement that we took. So 25.0 grams has 3 sig figs in it. If I'm going to round this to 3 sig figs, I have 2 options. So I can say 10,500, or I can do scientific notation and do 1.05 times 10 to the 1, 2, 3, 4, 10 to the 4th. And both of these are going to be in kilojoules. Okay, so it's a lot of information, but hopefully if you can go back and rewind and look back at different parts of this video, that will be helpful to you. If you have questions, please message me on Schoology. At some point, we are going to set up a video conference so that you guys can ask questions that you have, and I will do my best to answer them with this distance learning model. So you guys let me know if you need anything, and good luck studying for this.